Oh, well, there goes the car. Hi, Year 8s. I'm back. And this week we are starting off with a discussion about probability. What is the probability that I roll the 6? How about that? What is the probability I roll the 6? How many numbers are on a dice? Right, so let's get into it. Main activity today is I need to discuss this rule. There is a particular rule for probability of multiple events, and that rule states that the probability of any given event is, well, the number of events where your outcome happens divided by the possible number of events. So, in terms of me rolling a 6, there's only one outcome on here that has a 6 on it. And how many different outcomes are there on a standard dice like this? There are 6 different outcomes. So one outcome is the one I wanted out of a total of 6 outcomes. So the probability of me getting that is 1 over 6 as a fraction. That's the rule. We can all go home now. No, unfortunately, we have to take it to the next step, and that is where we've got multiple events. So today, as the big example, I'm going to flip a coin. That was a bad flip. Oh, that was a bit better. I'm going to flip a coin where we can get heads or tails, and I'm going to roll a dice at the same time. I've got 2 things going on. So, the first challenge is represent a coin flip and dice roll in a table. I notice some people don't like the term sample space. Do you realise that merely drawing this table that I'm about to draw shows the sample space? The sample space is simply the different options, the different things that can happen when I flip my coin and roll my dice. So, one of the outcomes would be 3 in heads or 6 in tails, right? All of those different outcomes together represent the sample space. The sample space is just all of your different possible outcomes. So let's do that. Let's make our table. And then we're going to do some cool questions. Okay, maybe that depends on your definition of cool. So 1, 2, 3, 4, 5, 6. So I'm going to put the dice up here. And I'm going to put the coin over here. So I'm just going to go H for heads and T for tails. The heads is the one that, has the face on it. I'm not sure who this is, but you might. So the different combinations we can then fill out in the table. So we just, one of our outcomes is here. The dice can be anything from 1 to 6. The coin can be heads or tails. We fill out this bit here, and it will tell us all the different possibilities that we can get from our coin flip and dice roll. So I'll use black. So we can get a heads and 1, heads and 2, heads and 3, a heads and 4, heads and 5, heads and 6, then tails and a 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5, tails and a 6. That's the sample space. That there. All of those options are the sample space. I could write it as a list as well. Just because I can, I'm going to show you the sample space written as a list as well. So, sample space as a list. All I would do is list all those different outcomes that you can see in there. So, H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, T6. Both of them represent the sample space. That's the sample space as a table, that's the sample space as a list. Now, the important thing today is you need to be able to answer a range of questions interpreting this, the probability of different possibilities happening. So let's do that. Oh, it doesn't even show. There we go. The dice isn't going to show. All right, so here's an example of the sort of question. I'm going to go, what's the probability of me getting a 4 on the dice and heads? So I want a probability of getting, well, this outcome. How many outcomes in our list give us a 4 and heads? There's only one, right? There's only one outcome that's the 4 of heads. So it's going to be 1 out of, how many outcomes are there in total? If you count up those number of outcomes, how many do you get? I'm hoping you noticed that by now there's 12 different outcomes, right? 2 times 6, it's going to be 12 outcomes. The probability of getting the 4 and the heads is 1 out of 12, right? 1 outcome out of 12 possible outcomes. Question, that's a simple enough one, but we're going to make them get a bit weirder. What's the probability of getting a 2? How many outcomes involve getting a 2? Well, if I think about it logically, there's 2 with heads and 2 with tails. There's actually 2 different outcomes that will be listed here that would give us a 2. So 2 outcomes out of 12 this time. There's something naughty about that fraction. I hope you realise it. It needs to be simplified. Both the top and bottom can be divided by something. They can both be divided by 2. So again, it's expected you automatically do simplify where possible. So yeah, the probability of getting a 2 in this situation is actually 1 out of 6. Let's do another example. What's the probability of tails? How many outcomes would give you tails? Well, as long as this is tails, there's each different outcome here is still going to be a tails outcome. And we can look at the table as well. All of those outcomes involve tails. 6 of them, right? There's 6 outcomes out of 12 that involve tails. You should be able to simplify that. 6 out of 12. Divide both the top and the bottom by 6, because they're both divisible by 6, biggest number that goes into both. It's a half. Some of you out there probably would have realised from the start it was a half, and I recognise that. But anyway, it's a half. We'll do a couple more interesting questions. What's the probability of you getting an even number? So even numbers are ones that are divisible by 2 into whole numbers. So, 2, 4, and 6 here are even numbers. How many outcomes involve even numbers? Well, it's all of these, the ones with 2s, all of the ones with 4s, and all the ones with 6s in it. Again, there's 6 outcomes there out of the 12 that would give you even numbers. Simplify it to 1/2. All right. Now, next up, a bit of a weird one. Probability. I want to know the probability of heads or tails. So heads or tails. Bit of a trick question. Every single outcome there involves either heads or tails, doesn't it? All 12 outcomes involve heads or tails. You can't get any outcome in that table that doesn't involve them. So all 12 outcomes involve heads or tails. So it's 12 over 12, which is just 1. 12 parts out of 12. If you cut a pie, if you ate 12 pieces out of a 12-piece pie, you've eaten the whole pie, right? 12 over 12, it's 1. And the last one I'm going to do in this set is the probability of rolling a 7. So if I've got my dice here and I roll it, what's the probability of me getting a 7? There is no 7. That's 0 outcomes out of 12, which is just 0. The probability of getting a 7 is 0. You cannot get a 7. Now, the examples in the text are slightly different, and all of them at some level though involve you being able to build tables like this. One outcome on the top, one outcome on the side, filling out the values in the middle, and then answering probability questions just like that. So it always comes back to the number of your event outcomes, like when we said the probability of 2, there were 2 of rolling a 2. There were 2 outcomes that match that. It's always the number of your event outcomes divided by the number of events. That little hash symbol there, it doesn't mean a Twitter thing or whatever you want to think it is. I'm using that as a quicker way of writing number. It means number. So number of event outcomes divided by number of events. That's what we've done in each and every one of these cases to work out the probability of an event. And remember at the end that you do have to simplify. But that's basically it for the content on your first lesson this week. Have fun. This is great stuff. It actually feeds into some remarkably enjoyable mathematics, and I hope you have a good time with it. Bye.